So this is the system given. We are asked to find rise time and the settling time for this system. Okay. Now there is formula to find the rise time and settling time, but let's say you don't remember the formula, right? How to solve in general, and what's the foolproof way of solving this circuit. So what's the transfer function? 1 by s into 10 by s plus 10. So this is the right. How this circuit? So this is in s domain, right? So we need to convert it into time domain. How to do that? First of all, let's find the do partial fraction of this, right? So this will be a by s, this will be b by s plus 10. Okay, so this will make it will be easier to convert it to time domain once you do the partial fraction, right? So we need to find the a and b coefficients. To find the a coefficient, what we need to do is hide this s. Okay, if you hide this s and substitute with 0, so s equals to 0 if you make, so then this will become 10 by 10, which is basically 1. So this becomes 1. B, what you will do? You will do the same thing. So we are trying to find the coefficient for the s plus 10 one. You will hide this, right? So if you hide this and make it 0, means s will become minus 10. So 10 by minus 10 minus 1. So this will become basically minus 1, right? And now converting it to time domain is easy. 1 by s is 1, right? And 1 by s plus any coefficient becomes e to the power that coefficient to t. So this is the time domain, okay, of this system. This is the transfer function in time domain. So you are saying what's the rise time for this one, right? So basically how it looks in the graph. So you are saying it will reach 1. So when t is equal to infinity, this will become 0. So it will reach 1. So it will reach 1 in the time t is equal to infinity. And what will happen in t is equal to 0? This will be 1 minus 1, 0. So it's starting from 0 and then going towards the infinity, towards the 1 in time infinity, right? So when we are asked to say the rise time, right? So what does it mean? So it will never reach 1, right? Because it will reach 1 in infinity time. So by definition, rise time is given by when it's 10% and when it reaches 90%. Okay. So this time we are asked to find. This is the rise time. Okay. By the way, this is overdamped system. Okay. So this is overdamped system. So it looks like this. If it was underdamped system, then it would have some look like this. So in this case, the rise time is 100%. The time to reach 100%. But here, since it never reaches the 100%, so it's still the 90% and starting from 10%. Yeah, so we are asked to find for this one. So now, when does this equation becomes 0.1, right? So it will become 0.1. Let's say this is your T1, T2, T1. Okay. So you'll do e to the power minus 10 T1 is equal to 0.9. 10 T1 would be equals to log of 10 by 9, right? Yeah, equal to log of 10 by 9 by 10. What will happen to T2 this time? 1 minus e to the power minus 10 T2 equals to 0.9. The power minus 10 T2 would be 0.1. 10 T2 would be ln 10. It is ln 10 by 10. This minus this, what will happen? This minus this you do, you'll get TR ln 9 by 10. Okay. So I think this will approximately be 2.2 by 10. It's 0.22. So that's the rise time. Okay. Now let's find the settling time. So what's the definition of settling time? Settling time would be here the time where it reaches 2% of its max value. Basically, it reaches the 98% of its max value. Okay. So time to reach it's 0.98, right? That means e to the power minus 10t becomes 0.02, 10t becomes ln to the power 50, t is equal to ln 50 by 10. Okay, and this turns out to be, I think, 0.4, right? So that's the answer for settling time.